Welcome everyone, and thank you for attending today's webinar on enhanced software quality with AI-powered static analysis. My name is Ricardo Camacho, and I'm an evangelist at Parasoft, focused on the embedded industry. And I'm accompanied by Miroslav Zielinski, Director of Product Management for our C and C++ solution offering. Mirek, let's greet our audience.
Hello, everybody.
Thanks, Mirek. Today's agenda is going to focus on how Parasoft has integrated AI into the static analysis workflow. Currently, our AI solutions can prioritize static analysis violations, perform triage by identifying and ranking the most critical issues. Then, in addition, with generative AI, we further enhance the static analysis process by recommending AI-generated code fixes on your identified coding violations. This is actually some pretty exciting stuff. But first, I'm going to put some context around static analysis and the value that Parasoft offers with its homegrown static analysis engine, then how we have evolved our solutions with the use of machine learning, again, to prioritize all your identified coding violations, and I'll actually give you a quick demo of that. Then we will jump into how we use generative AI to generate code and propose that code as your fixes to your violations. Anyways, Mirek is going to demonstrate this capability for you, and then what we'll do is we'll finish it up with live Q&A. Static analysis is the evaluation of the source code without having to execute it in order to identify defects early in the software development lifecycle. For example, coding defects that pose safety risks, such as memory leaks, threading problems, division by zero, and many other coding defects that can also crash the application or have it function in a way that it's unsafe. And in safety critical systems, these failures can cause death or harm to people. Static analysis can also identify security vulnerabilities, such as buffer overflows, the use of libraries with known security vulnerabilities, weak cryptography, framework-specific command injection errors, and can also provide metrics on the code, such as maintainability, portability, complexity, and other types. Now, static analysis can also ensure that software engineers adhere to the organization's coding rules. I remember many decades ago having to do walkthroughs with my peers as a way to ensure compliance to the organization's coding rules, and also in identifying code issues. Today, this can be done automatically. For example, Parasoft's static analysis engine performs pattern-based static analysis. It identifies known coding patterns or coding constructs that can cause unpredictable behavior. Data and control flow analysis is another static analysis technique that performs a simulation of execution, taking into consideration the data and the control flow to identify paths that could trigger runtime defects. Defects like the use of uninitialized memory, use of null pointers, division by zero, and memory leaks. It exposes bugs that evade pattern-based static analysis. It's much like performing unit testing. If you are not performing static analysis, you should be. What it also does, it shifts left testing, so you can find defects earlier and fix them when they are actually at the cheapest in the software development lifecycle to actually fix those issues. Also, our customers inform us that they are experiencing less defects reported from the field, higher quality code is being released, and there's also a very noticeable savings in labor. All right, let's talk about industry coding standards. There are well-defined and industry-accepted coding standards like MISRA, AUTOSAR C++14, CERT, CWE, OWASP, and many other standards actually. Some of these standards like MISRA are developed by a collection of individuals from various companies that contribute their many years of experience in software development to define the best coding rules and guidelines. In fact, Parasoft is a contributing member of the MISRA C and C++ working group. MISRA is the de facto standard for C and C++ in developing safety and security related electronic systems or embedded control systems. You also have the Carnegie Mellon University SEI CERT, Secure Coding Standards for C and C++, and actually Java. And you also have coding standards like the Joint Strike Fighter Air Vehicle or JSFAV from Lockheed Martin. It's a C++ coding standard to help produce error-free code. Now, I've also included MITRE's Common Weakness Enumeration, CWE. Technically speaking, CWE is not a coding standard. It's a list of software and hardware known weaknesses. The list includes common programming errors, design errors, and architecture errors, any of which may lead to exploitable vulnerabilities. However, many of the listed weaknesses can be identified through static analysis, which Parasoft supports to help ensure compliance to CWE. Of course, in conjunction, users can also apply unit testing, integration testing, API testing, and other testing methods that Parasoft provides to help ensure security. Now, CWE also puts out a list of the top 25 most dangerous software weaknesses. There is also the open source OWASP Foundation that produces freely available articles, provides methodologies, documentation tools, and technologies in the field of web application security. They also produce an API security top 10 list, which includes the most pressing security threats facing today's complex API ecosystem. Parasoft provides the most comprehensive code standards coverage. For example, we support the complete MISRA C 2023, MISRA C++ 2023, CERT C, C++, and actually all of the other standards that we support, they're fully supported. We also provide a utility for users to create their own rules or blend or customize existing coding configurations together to make their what they see as their ideal. All right. Now that we know the value that Parasoft offers by identifying coding violations, let's dive into our modern use of machine learning to perform prioritization of coding violations by ranking the most critical issues. You can see in this infographic, starting at the top, that you run your static analysis on your code. You can plug our static analysis in your CI/CD pipeline or in an IDE-centric type of deployment, whichever you decide, or both. What happens next is that the identified coding violations can be exported to our centralized reporting and analytics tool or solution called DTP. In DTP, this is where the machine learning happens as the code violations are marked as fixed, suppressed, and there are other labels like reassigned. The key thing here is to make sure you define a process where either you mark the coding violation in DTP fixed first or later. For example, you can mark the code violation in DTP as fixed and then go fix the violation in the code, or you fix the code and then mark the violation in DTP as fixed. Either way, the training of the model is happening as you perform this activity that I just mentioned, and you can do this through various sprints. So you're doing it cyclical. Also, we will let you know when the model is trained enough to actually provide valuable prioritization. So let's actually talk about that training and how it happens. Now, there are a couple of ways to train the model. One is manual, as I mentioned in the previous slide. The scenario is that you are starting from scratch. So at every sprint, as you identify and fix your violations, you are also actually concurrently training the model. Initially and commonly, all severity 1 coding violations must be fixed So these are commonly selected and marked as fixed so that the model learns that these are the ones to address first. The machine learning will prioritize these violations at a 100% remediation value. That means that you must fix this first. As your team fixes their other severity level violations, the machine learning continues on this education until it tells you that it has learned enough now to know how to prioritize your other identified coding violations. Now, the other option is through historical data. In this scenario, you are an existing customer and now want to adopt this machine learning capability. Having used DTP to track your coding violations in the past as fix, suppress, or other labels that we provide, this historical information is plenty enough for the machine learning to very quickly train itself. Okay, so this is a snapshot of a project in DTP. It's a C project, as you can see from the background. There's a file called lemon C. There's several violations. There's already some predictions that have happened here, and there's the project has been trained. So instead of taking you through a project that's been completed, I'm going to take you to another project and kind of step you quickly through that. It's partially completed, so it'll allow me to kind of show you some of the actions to perform. All right, so I'm going to go ahead and take you there. And this is the project. It's a static analysis project. You're going to see a lot of widgets here: violations, violation by authors, violation by assignee, because you could assign these violations to be fixed for to different developers. Anyways, I'm going to scroll to the bottom because this is where I have my static analysis machine learning widgets that I'm really interested in. There are currently, 8,000 violations still to fix. There's so many to review. There's so it's at 76.2% that still need to be fixed. And then there's this bar graph here where some of these violations have already been assigned different values. So, for example, there's 1,000 that's assigned at 20%, the action to be fixed. 40% of them, so it's a higher number that they should be fixed. And then there's still quite a few here that 4,873 violations that also need to be fixed. So again, you have these very high numbers telling you which violations need to be fixed. And let me go ahead and take you to the project here, to the violations. As we can see, some of these, again, there's history, so some of these have been fixed, some of these have been suppressed, some of these you can see that it says none. So when you go ahead and you know that you're going to fix a violation, you go ahead and you fix it within your IDE, and you make sure it's fixed. You can also come here and then you can take that action and mark it as fixed, or depending on your process, you mark it as fixed and then you go ahead and you fix it. So all this data is being collected, and initially you want to train your model. So to do that, you can click here on machine learning. But since the model's already been partially trained, I'm going to go ahead and recommend violations to fix. But initially, you're going to click train the model, and as you mark your violations as fixed or suppressed or so forth, you are continuing to train the model until this arrow now is at the green. That means that your model is well enough trained to provide the predictions of which violations should be addressed next, and it gives that percentage that I showed you earlier. All right, so let's go ahead and just recommend some violations to be fixed. So I'm going to hit next. DTP will use the machine learning model to make recommendations. Okay, great. So we're going to go ahead and confirm that. You can now see that it's giving you some metrics here, 8,059 recommendations to fix. So I'm going to go ahead and close that. And when you close that, you can now see that there is a recommended column. So now these particular violations have now different values. You can see some at 80, some at 60, at 40, at 20, and so on and so forth. So now you know which ones to address based on that recommended percentage value. All right. So that's kind of all that I wanted to show you for this. The exciting part is the generative AI. So let's jump back to our presentation and we'll move forward. Let's now explore how Parasoft leverages generative AI to accelerate the process of fixing the coding violations. Now, this innovation is truly a game changer. Parasoft is at the forefront of advancing software testing by continuously evolving and providing solutions that benefit the entire software development industry. This is really our commitment to the market, and it's to deliver the best tools on the planet. And to achieve this, we've enhanced C++ tests by integrating AI capabilities from GitHub Copilot directly into our VS Code extension. However, what sets us apart is our unique approach to the AI integration, which is to ensure that the recommendations produced are really high quality code. And the key to our success lies in actually these two critical elements. First is the rule documentation. By embedding detailed guidance from the compliance standard, we ensure that the AI understands the context and requirements for each coding standard. Second is the chain of thought reasoning. This technique helps the AI approach problems step by step, resulting in more complete and robust fixes that align with best coding practices. Now, these two approaches gives the AI clearer instructions and better context, which significantly enhances the quality of its output. And you'll probably see this in the demo. All right, let's touch on some of the benefits. Now, benefits to our approach include accuracy. Our fixes are more complete and robust, reducing the chances for false positives and missed issues. This saves time and allows teams to make real progress. Another benefit is compliance. Because we include the standard as part of the input, therefore, every fix aligns with critical safety and security standards such as MISRA, CERT, CWE, or whichever coding standard you actually decide to use. This ensures your code meets that industry requirement. Another benefit is that we manage complexity. Not only does our solution excel in large safety critical development environments, but you will see this in the demo. Tailored prompts ensure that even the most challenging violations are addressed effectively. And our solution has a direct impact on your business. It reduces labor by assisting developers in fixing identified code issues. So it accelerates timelines and allows your team to focus on innovation and meeting whatever other deadlines they may have. Now, the table that you see in this slide is the result of a study that we performed when comparing just Copilot generated fixes to our C++ test fixes that provide reasoning and also actually without reasoning. You can see in this table just a few small sample of a few rules violations that are being compared, but we actually have quite a large comparison. But the difference in performance between Copilot and C++ test is pronounced, and comparing C++ tests with reasoning prompts perform slightly better than without reasoning prompts. Anyways, by choosing Parasoft, you're not just adopting another tool, you're actually investing in a solution designed to empower your teams to deliver high quality, compliant code. Okay, I'm now going to pass it over to Mirik, where he will dive into the details. I believe you're going to find this very enlightening. Okay, over to you, Mirik.
Thank you, Ricardo. So let's see how our new Copilot extension helps developers be more productive when working with static analysis findings. What you can see here is the VS Code with the latest version of the C++ test extension. I just ran static analysis locally, and my goal now is to fix all the problems before opening the pull request. I've got quite a few violations here, and for each violation, I need to analyze the issue, understand the root cause, think about the optimal correction strategy, and finally modify the code to fix the problem. This all takes time, especially when multiplied by the number of violations. But with the latest C++ test VS Code extension, we can employ AI to help us with these activities. Let's see it with an example. Here I have a violation of avoid division by zero rule. Instead of studying the violation body, we can start by invoking the new explain violation action. C++ test extension will now build a prompt for Copilot to help us with the problem. The prompts that C++ test VS Code extension builds use source code, rule documentation, and additional violation properties to ensure optimal Copilot response. And as you can see in this panel on the right-hand side, we have the result. The response includes the explanation of the violation with the actual variable names from the source code. This verbal description of the violation makes it easier for me to understand the problem. It gets even more helpful for really complex issues. The best part, however, is that we get a source code automatically generated with suggested fixes. Here, I'm fully satisfied with how the problem was handled. That's exactly how I would fix the violation. So I will automatically apply this code. And as you can see, the code in my editor was modified in an intelligent way. In some situations, the suggested fix may not fully apply, but even then, the response we get should be an excellent starting point. Alright, we're done with one violation. Let's see how our new Copilot extension handles another violation. Here, we have a problem related to SQL injection. It seems that external data is used for the SQL query without any validation. Let's start again by querying Copilot for more information. The short description we got in the response to our prompt clarifies the essence of the problem. It's now clear to me that this implementation makes my system vulnerable to hackers' attacks, and I may easily lose my database. This is a serious issue, and I need to fix it in the right way. The suggested correction is excellent. Please note that we didn't get a trivial hint to add an if statement to validate the external input. This would not be easy to implement in a satisfying way. The response to the prompt that C++ test generated suggests using parameterized SQL queries, which is a proper way of implementing this kind of functionality. It's a type of a hint that my senior colleague would drop when reviewing my pull request. This is a huge value. It helps me, the less experienced developer, to be more productive. So I'm happy with this suggestion and I'm going to apply it. The suggested code still requires a few simple tweaks, but I know now the best approach to fix this kind of problem, so I'm almost there. And this concludes our short presentation. In just a few minutes, we resolved two non-trivial problems. A good result. Ricardo, passing back to you.